Greetings, everyone. Welcome to today's presentation. QReplica 3.0 provides synchronous and asynchronous replication solutions. With Replica 3.0 feature, DR can be achieved with simple and easy orchestration. In this seminar, synchronous and asynchronous replication concepts and detail procedures will be introduced for having best practice of DR mechanism. DR is about preventing total failure of mission-critical business systems and to recover within minimum time and impact. Preventing data loss requires a continuous data protection method. This includes preparation for and recovery from events of human error, software and hardware failure, network down, internal or external power failure, and all other events. To beat this challenge, IT managers must plan for redundancy of one or more backup systems at different locations. This involves constant or periodically data duplication to infrastructures at different sites to ensure business continuity from constant availability. RPO and RTO are the two most important parameters in a disaster recovery. To achieve continuous data protection, you must understand these two key indicators that measure acceptable business risk. These goals can guide companies in choosing the best data backup plan. RPO refers to the maximum amount of data loss that the system can tolerate. It refers to the time point corresponding to the recovered data after the business is restored. The RPO depends on the update level of the data recovery. This update level can be the last day. The backup data can also be 1 hour ago data. This is related to the frequency of data backup. In order to improve RPO, the frequency of data backup must be increased. RPO is an indicator that reflects the integrity of data restored. RTO is the duration of time the system can tolerate service interruption. For example, if the service needs to be restored within half an hour after the occurrence, the RTO value is 30 minutes. The RTO is only the time period between the occurrence of a failure, from the moment when the system goes down and the application stops, to the time when it is restored to support the operation. RTO is an indicator reflecting the timeliness of business recovery. It indicates the time required for business to recover from interruption to normal. The smaller the RTO value, the stronger the data recovery capability of the disaster recovery system. The IT administrators can deploy many disaster recovery systems. Obtain the smallest RTO, but it means investing a lot of money. The RPO indicator comes from before the failure occurs, and the RTO indicator comes from after the failure occurs. The smaller the value of the two is, the time interval can be effectively shortened from business transition period to normal. Traditional backup and recovery techniques, such as tape backup or disk-to-disk, are measured in hours. It will take a long time for them to recover, such as several hours to several days. Disaster recovery techniques such as asynchronous replication are usually measured in minutes. In the event of an accident, the recovery time will be reduced to a few minutes. Another more stringent business continuity goal is measured in seconds, usually with no data loss at all. Synchronous replication technology can achieve this. Asynchronous replication is a block-level differential remote volume backup function through LAN or WAN. In the beginning, replication will copy all data from the source volume to the target. It is also called a full replication. After that, use snapshot technology to perform incremental replication. Asynchronous replication uses the ISCSI function to establish a replication connection. It can use the full bandwidth of the allocated network port to achieve the best backup speed. However, in order to balance replication traffic and non-replication traffic, the traffic shaping function can help reserve the necessary bandwidth for non-replication I/O. Asynchronous replication can achieve the same data protection goals. However, the method and frequency of data replication are different from synchronous replication. Asynchronous replication commits writes at the source and then send the acknowledgement to the application on the host. The accumulated writes committed on the source volume will be copied to the target volume in batches at scheduled intervals. Synchronous replication is a block-level volume backup function through LAN or WAN. It is a timely replication function that can always synchronize source and target data. It uses ISCSI function to establish a replication connection. The replication task can use the full bandwidth of the assigned network port to allow the best backup speed. We assume that the synchronization source port must be greater than or equal to 10 GBPs to ensure normal operation. However, the synchronization source port in the source storage is not limited to the dedicated one. In order to balance replication traffic, it is still recommended to separate the port of incoming data from the host and the synchronization source port to the target storage. Synchronous replication can ensure data consistency between the replication source and target. This can be achieved by ensuring that every write I/O requested from the applications on the host will be completed after the host obtains the confirmation between the source and the target. If the write I/O cannot be committed on the source or target, the write operation will not be committed to ensure consistency. In addition, write failures are sent back to its applications on the host. Then, application error handling will determine the next appropriate step for the pending transaction. 1. The application on the host sends a write request to the source volume. 2. The write I/O copies to the target volume. 3. The write I/O at the target is committed to the target volume. 4. The write commit at the target is confirmed back to the source. 5. The write I/O is committed to the source volume. 6. Finally, the write acknowledgement will be sent to the application on the host. When a user creates a synchronous replication task, it will automatically copy all data from the source volume to the target at the beginning. This is also called full replication. At the same time, the source system will record a fracture log to maintain the block whether has been synchronized. The fracture log is a bitmap saved in the source storage to indicate which block of the source have been updated. It is invoked when the target of a replication connection is lost for any reason and becomes out of sync. For example, when an incident such as a network interruption occurs, the source cannot replicate the data to the target. I/O from the host will continue to be written to source. The fracture log is kept update until the incident is resolved. The source will learn about the unsynchronized blocks and replicate them to the synchronized state. If a network error still occurs and the replication is blocked, the system will issue a warning every 20 seconds and enter the failed state after 60 seconds. Therefore, the task will be stopped. At this point, if you want to continue the task, you must start it manually. Another operation is that the user can manually stop the task until the user manually resumes the task. The situation is the same. If you are not sure whether the target has been touched, you can also perform a full replication first when restarting the task. Both synchronous and asynchronous replications have their advantages and disadvantages. Before choosing a backup method, you must understand the risks of disaster recovery. Synchronous replication ensures that every data written to storage is saved locally and remotely. This can ensure zero data loss in the event of a disaster. So RPO is 0. In a synchronous replication solution, there are also trade-offs. Since each write needs to be saved locally and remotely, any problems affecting the source or target storage or the replication link between these two will affect the application in terms of latency and availability. As the distance between the source and target increases, this response time also increases. It is recommended to ensure that the link delay between the source and target is less than 10 ms. The converted distance is about 100 kilometers. Synchronous replication is mainly used for mission-critical applications that require instant failover when the source site fails. Although synchronous replication is usually used for disaster recovery, it is preferred for applications that cannot tolerate data loss and have a short recovery time. Asynchronous replication is mainly used to replicate data over long distances. It does not affect host I/O latency because once host writes are saved to the source storage, they are acknowledged. Since write operations are not immediately copied to the target, all writes will be tracked on the source. This data will be copied during the next synchronization. Therefore, RPO should be an acceptable amount of data, which may be lost due to failure. And RTO is equal to the period of the next synchronization. This time, increment also affects the amount of data that needs to be replicated during the next synchronization and the amount of potential data loss in the event of a disaster. Of course, the perfect solution is that both RTO and RPO are 0. This means that when a fault occurs, the system will respond immediately and there will be no data loss. To achieve this goal, the system design is extremely complicated and the cost is very expensive. So it should avoid falling into the vicious circle of simply pursuing the improvement of the two indicators and combining the actual situation. Appropriately improving the two indicators according to local conditions is the right way. This section describes remote replication prerequisites. First, list the parameters of remote replication. The maximum replication task quantity per volume is 1, and the maximum replication task quantity per system is 32, which including both synchronous and asynchronous replication tasks. Now we will demo how to achieve sync replication disaster recover solution with ESXi VMs. First, create source pool, source volume, and host group on source unit. Also, create pool volume and set this volume as backup volume on target unit. And create host group with this backup volume. In ESXi side, add static discover and then recan storage to recognize source volume. After that, you can see source volume as storage devcs on SC. And then clock new data store. Select source volume DS and click new virtual machine for VM creation. Click the plus icon in the Protection Groups pane to pop up a wizard and select Source Volume. Select Sync Mode and select Target Unit Information. Once Protection Group process done, you will see Sync Process Start and also completed. After sync completed, now let's test how to disaster recovery work in this scenario. First, remove VM and also unmount data store from source volume. Second, delete protection group and source volume host group. Rescan storage to make sure VM and data store is removed. Go back to target unit and set target volume property as RAID volume, and also add into host group with ESXi-IQN name. Rescan storage from ESXi side and then create new data store with target volume. Please notice to select Keep Existing Signature. After that, you can select Register VM to restore the same VM from source unit. This workshop discusses the various replication solutions. Configuring a data protection solution helps prevent unexpected situations, such as data loss. We provide local and remote data protection solutions to help easily recover in the event of a disaster. By using both synchronous and asynchronous replication solutions, data protection can be configured to meet the needs of enterprises. Synchronous replication usually writes data to source unit and replicas at the same time. In this way, the primary copy and the replica are always in sync. In the event of a disaster, synchronous replication can provide maximum protection and ensure zero data loss. Asynchronous replication first writes the data to the source unit and then copies the data to the replica, so there will be a certain delay in copying the data to the target unit. Asynchronous replication utilizes the snapshot technology to provide a consistent point-in-time copy that can be used in the event of a disaster. When using asynchronous replication, there will be no impact on host I/O because data will not be replicated when it enters the system. When data needs to be replicated over long distances, asynchronous replication can meet the needs of